Hello, my name is Mark. Welcome to my channel. Today I'm going to be talking about this diagram here, which is an AC to AC voltage doubler. And I didn't realize before that the voltage doublers out there are AC to DC circuits. And the DC isn't much used for anything, so they're not used very much. But this AC is better, and it goes from 120 volts to 240 volts here. And this was discovered back on December 15th, 2015. I didn't realize that back then. So I'll just zoom in here a bit so you can read it a little better. It's not too clear on this Amazon Fire tablet. Maybe the light's not too good in here. Okay, so I'll just kind of explain it here. First, this is a 1-to-1 ratio no-step isolation transformer. And this is the key component of the circuit, because what it is going to do is going to isolate the two parallel branches from each other so they don't short out. So we'll start with 120 volts here, and A and B is the straight through parallel branch, and C and D is the other parallel branch. And this line here is a series connection that connects the two together like two batteries in a flashlight. And this transformer isolates the two from one another. Actually, it isolates C and D from E and F because it's electromagnetically connected, not electrically connected. And it should be 240 volts to 240 volts no-step isolation transformer, because there's going to be 240 volts present at C and D on the secondary coil. And if it's 120 to 120 volt isolation transformer, then it could heat up and become damaged. And there's a serious problem in these countries with 120 volt systems because they don't have 240 volt no-step isolation transformers of the iron core type that I require. The other ones don't work properly, because I tried them out. So now, what does you have 240 volts here at G and J, and 120 volts drops over each resistor here. So the current's going up here. 120 volts drops over R2, and then another 120 volts drops over R1. But the current needed for R2 is recycled and pushed through R1. So it's like you're running two devices for the price of one. So if they're 100 watt light bulbs, for example, the resistance of each light bulb is 144 ohms, and each one requires 833 milliamps. So the input from the wall receptacle will measure 833 milliamps, when actually over 1.6 amps is required for the two light bulbs. So you're saving 50%. Okay, I can't think of anything else to say about that circuit. But I'll show you in this textbook here. I think it was copyrighted in 1984. About voltage doublers. And this next project I'm working on, I'm almost completed. And I'm just waiting for 4 capacitors to come. Should be here in a couple of days. Now, this diagram here is a half wave voltage doubler, part A there, and there's full wave doubler down there. And it puts out DC voltage over this capacitor C3. Now, I'm going to solve this problem by having AC at the output instead of DC. Now, what I do is I have 2 half-wave doublers, one drawn down here below this one, and then I have 2 capacitors at the output, and I connect them in series like I did on the other diagram I showed you with the transformer. And then I have AC at the output, but it's only 120 volts at the AC at the output, same as the input. It doesn't double it. Then what I do again is I create 2 more half-wave doublers down below in parallel with the input. And then I connect those in series. Then I should have 240 volts AC. If everything works out correctly, I hope. So what I'm going to be having is 12 diodes involved and 8 capacitors. So I've got this drawn out by hand, and it'll be my next video I'll be showing, I hope. And I will release the schematic diagram that I draw with the app digikey.ca/schemate. And I'm going to release it to the public as soon as I can. But the problem with the 240 volts is, how do you run 120 volt devices on it? I solved that with diagram 8, and I just have to apply that to this diagram also. So I guess that's all I want to talk about that. Let's have a look at that again. You can read that, how it works. Okay, thank you very much for watching.